Okay, number one here is kind of a long problem. But remember, we start out treating it like two separate problems. We're going to break it up around the equal sign, simplifying what's on the left side first and then what's on the right. So over here on the left side, we have the parentheses, so we're going to start there. Multiplying 3 times 4x gives us 12x. 3 times negative 1, negative 3. Negative 2 times 3x gives us negative 6x, and negative 2 times 4, negative 8. And then we have the positive 5x over here. What can we do with this before we move on? Is there anything else we can simplify, I should say? Yeah, 12x, negative 6x, and positive 5x make 12 and negative 6 make 6. 6 and 5 make 11. So that's 11x. Negative 3 and negative 8 make negative 11. So 11x minus 11. Any questions there so far? Okay, so now on the other side of the equation, we start out the same way. We have parentheses, so we're going to start 5 times 2x makes 10x. 5 times 6 makes 30. Next set of parentheses, 2 times 2x makes 4x, and 2 times negative 2, negative 4, and then we still have the positive 5. What can we combine now? 10x and 4x make 14x. What else? Perfect. So 30 and negative 4 make 26 plus 5 is 31. Then what? We've got an x on each side, so we should get rid of one. Which one are we going to get rid of? The 11x. We'll subtract 11x. So on this side, we have negative 11. Over here, 14x minus 11 is 3x. We have the plus 31. Solve this. What's our next step? Subtract 31. Negative 42 equals 3x, and then divide by 3. Negative 42 divided by 3 is a negative 14. X equals negative 14. Any questions? How many of you, with a show of hands, had that correct? How many of you would have if I'd have given you more time? Okay, is there anybody totally lost as to how to solve something like that? Okay, well, no hands on that part. That's a good sign. Number 2 here looks like it's a lot worse. I'm just going to erase some of this to make it so it doesn't clutter it up here. Number 2 looks a lot worse, but it really isn't. What's the first thing we're going to do to solve that? We got the x squareds, so let's get them all together. So let's get rid of one. What do we have to do to get rid of one? Subtract 7x squared. That would be gone. If we subtract 7x squared over here, what happens? It's gone as well. So the x squareds have disappeared. We've got to make sure we keep this as a negative 3 here. That's negative 3 plus 19. Over here, that's a positive 2x. It's just 2x minus 11. The x squareds are gone. This is just a regular equation to solve. What do we do first? We get rid of the negative 3x by adding 3x. So I've got 19 equals, what's 2x plus 3x? 5x minus 11. And then add 11. 30 equals 5x. And then divide by 5. 6 equals x. X equals 6. So that one's pretty simple once you get the x squareds to disappear. Number 3 over here is not necessarily a pleasant problem to do. So I'm going to rewrite it here. Let's see, minus 1/2 equals 7 over 2x. What do we have to do to start solving this? First thing we have to do is find what? Well, least common multiple or least common denominator. Our denominators here, we have 4, we have x, we have 2, and we have 2x. Remember, we start out by looking only at the numbers. For 4, 2, and 2, what is the least common denominator for 4 and 2? You're thinking greatest common factor. Least common denominator would be 4. If we're making them common denominators, halves and fourths would become fourths, right? For the variables, what do we do with the variables? The smallest power or the largest power? Largest. So the largest power is just the x. So 4x is our least common denominator. That means we're going to take this whole equation and multiply it by 4x. Now I'm going to make it 4x over 1 because these are all fractions, and it's easier to multiply fractions by other fractions. So we're going to do the 4x over 1 times 3/4. 4x times 3 is 12x. 1 times 4 is 4. 12x divided by 4 is 3x. Four x over 1 times 5 over x. On top, we've got 4x times 5 is 20x. And bottom 1 times x is x. 20x divided by x is 20. Good. Next, we have 4x over 1 times a negative 1/2. I'm going to put the negative 1 on top. Remember, the negative can either go with the numerator or the denominator, but it cannot go with both. 4x times negative 1 is a negative 4x. 1 times 2 is 2. What is negative 4x divided by 2? Negative 2x. Then we're at the equal sign. We have the 4x over 1 times the 7 over 2x. So on top, 4x times 7 is 28x. On bottom, 1 times 2x is 2x. So here the x's are going to divide out. So it's 28 divided by 2 is 14. Now what do we do? Combine. We've got the 3x and negative 2x makes 3 plus negative 2 is 1. So it's 1x or just x. Plus the 20 equals 14. Then what? Subtract 20 minus 20. X equals negative 6. What do you think? Having fun yet? Okay. One like that last one, by the way, on our test coming up. Our test, by the way, I think is 2 weeks from tonight, I believe is our next unit test. That would be an extra credit question if I asked you something like that with the variable in the denominator. In fact, when we get to that test, if I don't have an extra credit question on there like that, remind me and I'll give you an extra credit question with that in the denominator just to solve on that test. Okay, so we've solved some pretty tough equations. Let's review working with them. For example, we can run into something simple like 7 times a number increased by 8 is 43. Find the number. So this is a matter of just translating the words into our symbols and numbers or expressions, make an equation and then solve it. Remember, whenever we see the is, that generally corresponds to the equals sign. So let's look in front of it. 7 times the number increased by 8. How would I express that? There we go, 7x plus 8. Is my equals, so is 43. What do we do to start solving that? High energy group tonight, huh? Yes, we subtract 8. 7x equals 35. Then we would divide by 7. X equals 5. I'm going to have you guys try one. Four times the sum of a number and 5 is 44. Find the number. I'm going to give you guys a couple minutes in your notes to give that a shot. So what's the equation going to be? Is that the equation? Okay. Perfect. We have to have the x plus 5 in parentheses because it's 4 times the sum. And when we see that, it implies that the addition was done first. Then what? 4 times x is 4x, and then 4 times 5 is 20, and then subtract 20. So 4x equals 24, and then divide by 4. So x equals 6. Good. We can have our typical word problems that we've had before, like you're probably sick of these by now. The length of a rectangle is 11 more than the width. The perimeter is 462. Find the length and width. I'm going to give you guys a couple minutes here, see if you remember how to do this. I'm going to put a couple of notes up here as you guys are getting started, just to maybe give you a little kickstart in the memory if you're having some troubles. And we'll talk about this in a minute or two. Okay, so the key is we have to, of course, we're going to replace P here with the perimeter of 462. We have to replace either the L or the W with another expression that looks like it's in terms of the other variable. What are we going to do there? L equals W plus 11. Perfect. Because the length is 11 more than the width. So as we write this out, 2 times L becomes 2 times W plus 11 plus 2W. What's our next step? Two times W, yep, is 2W. And then 2 times 11 is 22. It's 2W. And then 2W and 2W make 4W. And then subtract 22. So is that 440 equals 4W. And then divide by 4. 110 equals W. All done? Not quite. 110 equals W, that's 110. We also have to find L, which is W of 110 plus 11, which is 121, is the length. We also had problems. Anybody have any questions on those perimeter problems like that? Okay. We also had angle problems. Where we might have had something like, oh, let me be 6x plus 11 and 2x plus 9. And I ask you to find each angle. See if you can find each of those two angles marked here. I'll give you a minute or two to work on that. So what's the relationship between these two angles? Remember, there's only a couple of different possibilities. Either they have to be equal to each other. Are they equal to each other here? No. They subtract to make a set difference. Do they subtract to make a set amount here? No. There's a reason why I asked that 1 second. The third possibility is they add up to a definite total, which is the case here. What do they have to add up to? 180. So we have the 2x plus 9 plus the 6x plus 11 has to add up to 180. Now we could have put the 6x plus 11 first. It wouldn't matter. Either way, we're going to get the same total here in this next step. We're going to combine the 2x and 6x, make 8x. Perfect. The 9 and the 11 make 20. So 8x plus 20 equals 180. So it didn't matter which one of these you put first, we'd still get 8x plus 20 equals 180. To solve that, our first step is to Subtract 20. 8x equals 160. And then divide by 8. X equals 20. Now, of course, we're not done yet. What do we still have to do? Yeah, we have to find each angle. And to do that, that's exactly right. We put x in. So instead of 6x, it is 6 times 20 plus 11. 6 times 20 is 120. Plus 11 is 131 degrees. Now, at this point, we can take a shortcut and just subtract from 180 to find the other angle. But I'm going to go ahead and put the 20 in for x just to make sure we get the right amount. So it's 2 times x becomes 2 times 20 plus 9. 2 times 20 is 40, plus 9 is 49. Do those two add up to be 180? They do. Okay, so that's enough of our review of equations and geometry. Let's take a peek at our new topic, and that is decimals. To understand decimals, we once again have to go back to that place value concept that we were looking at to start out our whole numbers. So our place values at the end, of course, we had the ones, the tens, the hundreds. Then we had the 1,000s, the 10,000s, and the 100,000s. Then the 1 millions and so on. Now I wrote them out numerically on purpose for a reason, to show the pattern that's developing here. As we move one spot from left to right, the place value is divided by 10. 1 million divided by 10 is 100,000. If I do the same thing from 100,000 to 10,000, that's divided by 10. If I keep going, same pattern continues. 10,000 divided by 10 is 1,000. Every time I move a spot to the right, the place value is divided by 10. Until we hit the decimal point. Then our place value, at this point we have stopped in the past, but our place values do continue after the decimal point. If we divide 1 divided by 10, it's going to be 1/10. Divide by 10 again is going to be 1/100th. Divide by 10 again is 1/1000th, 1/10,000th, and 100,000th. Now, a couple of things going on here. First, I always get asked why there isn't a ones place after the decimal point. There's not a once place or ones place of any sort after the decimal point because we have to divide by 10 every time we move. Well, I couldn't have a 1 over 1 because that would just be 1. There would be no difference in place value there. The second thing we want to point out here is you might be looking at these place values thinking they look suspiciously like fractions because that's exactly what decimals are. Decimals are nothing more than a shortcut way of writing fractions with a very specific set of denominators. In this case, those denominators are the powers of 10. So if I have 0.68, what that is really saying, first of all, you would pronounce that 68, and then you would name the place value of the last digit, 6,800. Well, that pronunciation is actually very telling into the meaning and the conversion of that. 68 hundredths is actually the fraction that that decimal represents. The place value of the last digit is the denominator of our fraction. So to change a decimal back into a fraction, it's really that simple. You just read the number after the decimal point and put it over that denominator of the last digit. Now, we would not leave it as 68 over 100 because both of those can be divided by 4. We would make this 17/25. If I had 0.0375, again, I read the number as though there's no decimal point there. It's 375. What would my denominator be? Well, that's over. The last digit is in the 10,000ths place. So it's 375 over 10,000. What am I going to do to reduce that fraction? Both divide by 5, that'll work. 375 divided by 5 is 75. 10,000 divided by 5 is 2,000. What's next? I can divide by 5 again. I'm actually going to jump up and divide by 25. 75 divided by 25 is 3. 2,000 divided by 5 is 80. 2,000 divided by 25 is 80. 3/80ths. If there is a number in front of the decimal point, like 6.044, just like fractions have mixed numbers, decimals have mixed numbers. And when we convert this into a fraction, it becomes a mixed number. The part in front of the decimal point is the whole number, the 6. So now we just have to find the fraction from the portion that comes after the decimal. That's going to be read as 44. This is tenths, hundredths, thousandths. Now I'm going to show you a little shortcut for double checking here. Like for the 375 10,000ths, there's 1, 2, 3, 4 decimal places. My denominator better have 4 zeros in it. Here in my 6.044, there's 1, 2, 3 decimal places. My denominator has 3 zeros in it. As I go to reduce that, 44 and 1,000 can both be divided by 2. Gives me 22 over 500. Are we done? No, both of those can be divided by 2 again, giving me 11 over 250. So this is 6 and 11 250ths. Any questions there? Okay, now, if I want to round these decimals, and we're only going to do a couple very quick examples of this, we have to understand the place values. So if I have 37.8453, if I want to round it to the nearest thousandth, what digit is in the thousandths place? The 5. So there's our thousandths place. We look at the next digit and only the next digit, the 3. Does that tell us, do we stay the same or do we round up? We stay the same. So that's 37.845. What if I asked to the nearest hundredth? What digit is in the hundredths place? The 4. The next digit is 5. Do we round up or stay the same? That is a 5, so we round up. So 37.85. We said to the nearest 10th. What digit's in the 10th place? The 8. The next digit is a 4. Was that round up or stay the same? Stay the same. Now, there's a common mistake that gets made on this one. And I don't know where it came from because there's no mathematical basis for it. But in the last couple of years, I've had several students tell me that they were taught to do this. And I don't know where it came from. Rounding the nearest 10th. This is the 10th digit, the 8. But I've had several students tell me they were taught, well, you start at the end of the number and you round back to it. The 3 doesn't do anything. The 5 rounds this up to a 5, and then that rounds that up to a 9. That is not how it works. You do not do repeated rounding. When you round with only one digit. There's a digit you're rounding to, and then there's the indicator that comes right after it. All the other digits after that mean absolutely nothing. Remember, when we are rounding to the nearest 10th, what that means is we're looking at a number line. And this number line is only numbered in tenths. So 37.8 and 37.9, exactly in the middle of this would be 37.85, right? 37.8453 is on which side of that? Yeah, it's somewhere in here. It's before that halfway point. So it is closer to this bottom one. So it is only that next digit that determines whether we're before or after the halfway point. The rest of these digits over here, they matter, but they aren't going to put you past the halfway point. Okay. Next, what if we want to convert then from a fraction back into a decimal? Well, of course, we all know that 3/4 is what is a decimal? 0.75. If we didn't know that, we would have had to take the numerator divided by the denominator, 3 divided by 4. Right, for right now, we would have to do that on the calculator to get the 0.75. Or we could take something like 5/8. Of course, what are we going to divide to turn that into a decimal? 5 divided by 8, which is, do it on the calculator, 0.625. A classic mistake that gets made here. Let's say I have 5/6. 6 divided by 5 is 1.2. What did I do wrong? Yeah, I mixed the numbers up. It is numerator divided by denominator. It should be 5 divided by 6, which is 0.83333333333. Second, is 5/6 bigger than 1 or smaller than 1? It is smaller than 1. 6/6 would equal 1, so 5/6 is smaller than that. No matter what form a number is in, its value doesn't change. Remember when we did fractions, we talked about you could have 5/6, you could change it to 15/18. I changed its appearance, but I have not changed the value. What I did there was I multiplied both the numerator and denominator by 3. The value doesn't change. If this is less than 1, This is still less than 1. Changing it from a fraction into a decimal still will not change the value. So there's absolutely no way I can come up with a number larger than 1 there. So be very careful of that. I usually catch a few of you doing that as we go through these. Well, since we got a few minutes before break, I'm going to show you one little thing. You will not be tested on this one, but it's one that's it's good to know. A lot of times you're doing calculations with measurements. And if you're doing like maybe working on construction where you're going to tape measure or designing something where you're going to have to go to the 1/8 or the 16th of an inch, you might calculate a measurement as 5.714 inches. And you need it to the nearest 16th of an inch. Now we've looked at converting it to exact fractions. If we're doing an exact fraction, this would be 5 and 714 over 1,000. And then we'd reduce that fraction. But we're not trying to do an exact fraction. We're trying to do to the nearest 16th of an inch. To do that, we're going to keep the whole, 5, and we need to find the fraction that is left by the decimal, the 0.17 or 0.714. To turn that decimal into a fraction, I'm going to do the easiest conversion to a fraction I know, which is to just put things over 1. Notice the decimal point's still there. I have not moved it at all. Right now, the denominator of this fraction is 1. What do I want it to be? 16, right? For 16ths. How do I turn a 1 into a 16? I multiply by 16. If I multiplied the denominator of the fraction by 16, though, what must I also do? Multiply the top by 16. So 0.714 times 16 is 11.424. What this is telling me is I am between 11/16 and 12/16. Which one am I closer to? Why is it closer to 11? Because it's 0.4. 0.4 is smaller than 0.5, so we go down to 11. If that were 0.5, we would go up to 12. So it is the 11/16. Now, again, I just wanted to show you that process so you'd seen it once. You will not be tested on that. It is time for our breaks. Let's go ahead and take our break. We're at 4:19. Let's come back at 4:29. That time, let's go ahead and get rolling. Okay, so our next step then, working with these decimals, is to do our operations with them. And I think at this point, we've worked with numbers enough and the rules for the operations with numbers, we should be able to move through this relatively quickly. So let's take a peek at addition and subtraction again. So the rules for addition and subtraction, if you recall, number 1 is when we add or subtract numbers, we must have the same name. When we're dealing with decimals, what that comes down to is place values. Just like it did with whole numbers, we had to line up the columns so that our place values were lined up. Well, to line up place values with our decimal numbers, that means you have to line up the decimals. So we line up the decimal points. Second, when we add or subtract, we always combine the counts, but when we add or subtract, we keep the same name. With decimals, that means Move the decimal point straight down. So let's look at some examples. If I have 27.34 plus 9.86, let's go 9.83. Let's do that. Actually, I wanted to go one more digit there. 9.836 is what I wanted. There we go. When I go to set this up, what do I have to make sure I do when I write in my second number here? Line up the decimal point. So I'm going to put my decimal point in first. I've got the 9 in front of it and the 836 after it. Technically, I should fill in the missing decimal place here. So that is 340 thousandths instead of 3400ths. Now they're both in thousandths. Here I have thousandths lined up with thousandths. So 0 plus 6 is 6 thousandths. Here I have hundredths lined up with hundredths. 4 and 3 make 7 hundredths. This is my tenths. 8 and 3 make 11. Just like any whole number I can carry, so I'm going to keep the 1 and carry the 1. Now, before I can do the 1, 7, and 9, what do I have to do? Bring down my decimal point. That is keeping the same name, bringing the decimal point straight down. I should never cross the decimal point without doing something with it. Now, the 1, 7, and 9 make 17. What am I going to keep? Keep the 7 and carry the 1. 1 and 2 makes 3. Again, just to emphasize, when I added these 3 and 8 made 11, but those were tenths. That 1 that I kept stayed in the tenths. By bringing the decimal point straight down, that guarantees that those stay the same place value that they were. When I subtract, it's the same way. Rather than getting carried away with examples, I'm just going to show you one example here. What if I have 12 minus 4.7836? I have to line up the decimal points. On the 12, where is my decimal point? At the end of it, yes. Any number, oops, my microphone just fell. Any number that doesn't have a decimal point written in it, the decimal point is at the end of the number. So then we're going to line up this decimal point with that. The 4 is in front. 7836 is afterwards. And we will need to fill in those missing zeros. Now, just like with whole numbers, we start on the right and work our way back to the left, and we subtract. Well, 0 minus 6 can't be done, so we're going to need to borrow. But we go here and there's nothing to borrow from, so what do? We're going to keep going. We're going to go all the way here to the 2. We borrow from the 2, and that'll be a 1. That makes this a 10. Now, we need to get it all the way down here, so we have to keep borrowing. Borrow from the 10, that's a 9. This becomes a 10. Borrow again, that's a 9, and this becomes a 10. Borrow again, that's a 9, and this becomes a 10. Now, this is one of those things that there are a lot of shortcuts people are shown for this. One of them is just to borrow here and just go 9, 9, 9, 9, 10 for the last one. Others are to subtract and go 1 less. Whatever your shortcuts are you've been taught, all those are shortcuts of this process. So now that we've borrowed repeatedly to get what we needed down here, we've got 10 minus 6 is 4. 9 minus 3, 6. 9 minus 8 is 1. 9 minus 7, 2. What's next? Move our decimal point down. We don't cross it without moving something with it. Now 1 minus 4 can't be done, so we're going to borrow. This is a 0, and this will be 11. 11 minus 4 is 7. Any questions there? Okay. So that's adding and subtracting. Multiplying and dividing. Remember, when we multiply or divide with numbers, first of all, we do not need the same name. What that means for decimals is when we multiply or divide, we do not need to line up decimal points. This is equivalent to in fractions. We didn't have to get a common denominator to multiply or divide. When we combine, we always combine the counts. When we multiply or divide, we also combine the names. So this is accounted for in a lot of ways. We're just going to say move the decimal appropriately. We'll look at that as we do our examples. So let's start out with an example of multiplication. If I have 3.47 times 5.8. When I go to set this up, do I have to line up my decimal points? No, I don't. When we multiply or divide, we don't need to worry about having the same name. Next, I'm going to do 8 times 7 is that everybody wants. 56. Thank you. So we'll keep the 6 and carry the 5. 8 times 4. 32 plus 5. 37. So 7, carry the 3. 8 times 3. 24 plus 3. 27, so 7, and there's no place to carry the 2, so just put it there. Before we move over to the 5, we have to remember to add a 0, and I always put a line up here so I know what's been carried. 5 times 7 is 35. So 5, carry the 3. 5 times 4, 20 plus 3 is 23. So 3, carry the 2. 5 times 3, 15 plus 2 is 17. So 7, carry the 1. And then I just add my count. Now notice, when I multiplied, I ignored my decimal points. This is the only operation where we don't have to worry about the decimal point until we're all done. So I had 6 and 0 makes 6. 7 and 5 is 12, so 2 carry the 1. 1 and 7 is 8, plus 3 is 11, so 1 carry the 1. 1 and 2 is 3, plus 7 is 10, so 0 carry the 1. 1 and 1 is 2. Where does my decimal point go? Right there, between the 0 and the 1, 3 place values. Why 3 place values? Why is it 3 place values? Perfect. We've been taught that you look at the problem, you count 1, 2, 3 decimal places in the problem. So you have to go 1, 2, 3 decimal places in the answer. Why? Well, because this is hundredths. This is tenths. Tenths times hundredths. When we multiply, we also combine the names. Tenths times hundredths has to give us thousandths. So counting those decimal places is nothing more than combining the names. Now also, we talked a lot at the beginning of the course about estimating. I would call this to be something about close to 3. 5.8 is close to 6. 3 times 6 is 18. I'm expecting an answer close to 18. If I put the decimal point here, 2.0126 would not make sense. If I put the decimal point here, 201.26 would not make sense. Either one of them is very close to 18. So by estimating, we can also conclude that the decimal point has to go there. Okay, division by decimals. Now, just like division with whole numbers and division with fractions had been changed and altered to the point where it looks nothing like the original process, division with decimals has been done the same way. Now, the original process with decimals and the way it's been changed, I'm not going to show you the original process because I feel it would be very confusing to you to see that because we're so used to the shortened process here. So we're just going to go ahead and look at the shortened process. So if I have 49.632 divided by 3. I'll go 3.4. To divide by a decimal, what have you been taught to do? Move the decimal. You're taught to move this over, get rid of it here. Once we move that, what else do we have to do? Yeah, move the other decimal the same distance. Why are we able to do that? Well, remember, division and fractions are kind of interchangeable. So if we turn this division problem into a fraction, what we're really doing here to move the decimal on the bottom over the one spot is I'm multiplying by 10. That moves that decimal point over a spot. If I multiply the denominator of a fraction, I have to multiply the numerator of the fraction. So 49.632 times 10 is 496.32. So this becomes 496.32 divided by 34. Now, if this were 2 decimal places here, I would have had to multiply by 100 or move them both 2 spots. 3 decimal places, it would have been 1,000 or 3 spots. As long as you're doing the same to both numbers, these rules of fractions apply and it stays equivalent. Okay, so down here, does 34 go into 4? No, so I'm going to leave it blank above the 4. Does 34 go into 49? Yes, how many times? Once. 1 times 34 is 34. What do we do? Subtract. 9 minus 4 is 5. 4 minus 3 is 1. So there's 15 left over out of that 49. What's next? Bring down the 6. Does 34 go into 156? Yes, it's not going to go 5, so we'll have to go 4. 4 times 4 is 16, so that's 6 carry the 1. 4 times 3 is 12, plus 1 is 13, so it's 136. So we subtract. 6 minus 6 is 0, 5 minus 3 is 2, 1 minus 1 is 0. So it is 20 left. I should always double check, by the way, that this number I get after I subtract is smaller than what I'm dividing by. If it ends up being bigger than that, I divided wrong. I have to go back and check again. Now, before I can bring down the 3, I need to move up my decimal point. Just like with addition and subtraction, even though division it follows very different rules, when I cross that decimal point, I have to do something with it. So I'm going to bring down the 3. 34 goes into 203 how many times? You try 6. 6 times 4 is 24, so that's 4, carry the 2. 6 times 3 is 18, plus 2 is 20. That didn't work, did it? Just a little bit too big. So this has to go down to 5. 5 times 4 is 20, so that's 0, carry the 2. 5 times 3 is 15, plus 2 is 17. We subtract. 3 minus 0 is 3. Got to borrow here. This is 1 and 10. 10 minus 7 is 3. I bring down my next digit, which is the 2. 34 into 332. Let's go 9. 9 times 34. Well, 9 times 4 is 36. That's 6, carry the 3. 9 times 3 is 27, plus 3 is 30. We're going to subtract here. Borrow, this is a 2, and this will be 12. 12 minus 6 is 6. 2 minus 0 is 2. That's 26. Now we're out of numbers here. Does that mean we're done? It could, but it doesn't have to be. We can add zeros and bring them down. Well, how do we know when to quit? Well, let's say I asked you to find this to the nearest thousandth. Well, if we're going to the nearest thousandth, we'll keep going. 34 goes to 260. How many times? Should we try 7? 7 times 4 is 28. So that's 8, carry the 2. 7 times 3 is 21. Plus 2 is 23. We subtract here. Or borrow, this would be 5 and 10. 10 minus 8 is 2. 5 minus 3 is 2. And 2 minus 2 is 0. Well, that 7 is in the thousandths place. We wanted to go to the nearest thousandth, so are we done? Say no. Why not? We have to add one more 0 and bring it down. So this is 220. 34 goes into 220 6 times. 6 times 34 would be 204. So now to the nearest thousandth, this is going to be 14 point what? 0.598. We had to go that extra place here so that we knew whether this stayed a 7 or if it had to round up to the next place value. If we're closer to the 7 or closer to the next one. Because it's a 6, we had to round up to the next value. Okay, so now now that we know how to divide those decimals, those numbers, let's take a look again at converting our fractions back into decimals. So if I have 3/8, to convert that into a decimal, that becomes 3 divided by 8. So I'm going to have 3 inside there divided by 8. Well, 3 does not go into, or 8 does not go into 3, and there's no other digits to use, so we're going to have to put our decimal point in, move our decimal point up, and then add zeros. Now, does 8 go into 30? Yes, it goes 3 times. 3 times 8 would be 24. We subtract, there's 6 left over. Notice, once I brought the decimal point up, I ignore the decimal point for everything else. I can add another 0. I bring it down. 8 goes into 60. 7 times. 7 times 8 is 56. That would leave me with a 4. Add another 0 and bring it down. That's 40. 8 goes into 40. 5 times. 5 times 8 is 40. There is nothing left over. So that is 0.375. Now I get asked all the time, do I need this 0 in front of the decimal point? The answer is mathematically no. 0.375 is mathematically correct. But depending on what field you are in, there are conventions that come into place here, especially if you're in a medical field, if you're in nursing or paramedic. I did that a little too obvious there. Let me do this. If you have that written like that, 0.8, it's real easy to wonder, is this really a decimal point or is it a stray mark? Well, if the 0 is in front of it, it's clear that that has to be a decimal point. Otherwise, you wouldn't put a 0 in front of the 8. So in most medical fields, I know at WITC here, they're strict about that. If you're asked to do a dosage calculation or anything like that, if it comes out to be 0.8, if you don't have that 0 in front of it, they will mark it wrong. And the only reason that is not because mathematically it's wrong, but because in those fields, you need to be able to look at numbers very quickly and understand them. And if you're looking at that quickly, when it's just 0.8, it would be very easy to mistake that for an 8 and not a 0.8. Obvious reasons why that's a concern. 0.8 milliliters, should be milligrams of morphine will make you really happy. 8 milligrams of morphine will make you really dead. So obviously there's your morbid thought for the day for Halloween. Okay, so last operation we need to cover, and then we'll get out of here for the night. Point 0.4 squared. Remember that is 0.4 times 0.4. Well, 4 times 4 is 16. Remember, we count the decimal places. There's 1, 2 decimal places in the problem. Has to be 1, 2 decimal places in our answer. That is 0.16. If I have 0.09 squared, how many decimal places is this answer going to have in it? 4, very good. There's 2 decimal places there. And if I multiply by myself, 2 and 2 make 4. So I'm going to have 1, 2, 3, 4 decimal places. 9 times 9 is 81. That's going to be 0.0081. What if I have 0.2 to the power of 3? Well, this is going to be 0.2 times 0.2 times 0.2. How many decimal places is that answer going to have? 1, 2, 3. Well, 2 times 2 is 4, times 2 is 8. So that's 0.008. There was 1 decimal place here, but to the power of 3, 1 times 3 makes 3 decimal places. There are 2 decimal places here, 0.05 to the power of 4. How many decimal places are going to be in my answer? That 2 times 4 makes 8. 5 to the 4th power is 625. And we fill in the zeros. Do you notice a connection here between anything else? If I had x squared to the power of 4, that was x to the 8th, right? Here I have 2 decimal places to the power of 4. That's 8 decimal places. It's the same type of relationship as with our exponents on our variables. Okay, with that, I'll let you guys off the hook. I'll let you have the last 20, 23 minutes here to get started on stuff if you would like. We do have a new quiz. It is due tomorrow, Wednesday, at 11:59 p.m. We do have a new homework due for Thursday at class time. And remember, test 3 is coming up 2 weeks from tonight. That'll be November 14th is our next test. I just wanted to give you a little heads up because this time of the year gets a little weird. The nice thing that does, it gets our test out of the way before you guys have the weird week for Thanksgiving. Okay, so you guys have a good night. I'll be here till 5:20 to answer any questions that come up.